Awesome. Hi, everyone. Let us know if you can see us. Give me a thumbs up or say something in the comments. In the meanwhile, perfect. In the meanwhile, we are going to be getting started. Thank you so much, Sarah, for joining us today. This is a workshop to learn more about Sway, and today we're going to be building a marketplace dApp on Fuel. We're super pumped to have Sarah. So, Sarah, before we get started on anything, would you like to give us an introduction about yourself and tell us a little bit more about you?
Sure. Yeah. Super excited to be here. Thanks for having me. So I'm a developer relations engineer and contributor at Fuel Labs, and I'm also developer DAO member, OG member, and I'm really excited to be here and finally be giving back to the DAO. So yeah.
Sweet, awesome. Thank you so much. So, yeah, before we jump into the actual workshop, we're just going to quickly intro what the goal of this workshop is. So, we're going to be doing a sponsored workshop with Fuel Labs, where Sarah's going to be walking us through how to build with Fuel. And the goal is behind the scholarship that we've launched, the DD Hackers. And the scholarship is to go to East Denver. The applications are due tomorrow at 11:59 EST. And you and a team get to pick a project that you're going to build, and Fluent is one of the sponsors. So if you build a project, you and your team submit the application, you tell us what you're building. You have a proven track record. It does not have to be only for developer DAO members and open to everyone. And the goal is for you to come to East Denver and build and have an awesome time. So with that said, I'm going to pass the mic off to Sarah, who's going to be getting us started.
Awesome. Thank you. So yeah, we're going to be building a marketplace dApp today. I was really excited. So first, just a really quick intro to what is Fuel. Fuel is a modular blockchain that can act as an execution layer for any other L1 blockchain. So you can think about it a lot like other layer 2 rollups like Optimism and Arbitrum. But some of the key differences are it uses the Fuel VM instead of the EVM. You can configure it with different blockchains. Instead of Solidity, you write contracts with Sway. And it has a whole suite of developer tooling and just generally superior developer experience. So some of the Fuel terminology you'll need to know is when I say Fuel, I'm referring to the Fuel blockchain network. Sway is the Rust-based domain-specific language that we're going to use to write a contract. Fork is short for Fuel Orchestrator, and it's the equivalent of Cargo for Rust or NPM for Node. And then FuelUp is the official toolchain manager for Fuel, so it manages and updates versions of Fork and all the other tools that you'll need. So what we're building is an Amazon-like marketplace contract. So basically anyone can list items for sale, anyone can buy them, and payments are sent instantly from buyers to sellers. So to code along with me, you're going to need either to open up this Sway Playground or install FuelUp. So I'll show you what Sway Playground looks like. It's sway-playground.org. And I can make that a little bit bigger. And so you can write and compile your whole contract here, but you can also do it locally, which is what I recommend. So to do that, we're going to need to install FuelUp. So to install FuelUp, you can go to github.com/fuellab/FuelUp. And that's what this looks like. There's also a link right here that opens up the official book for the docs. And there's an installation page there. You can also find the instructions in the README. And it's this one command right here to install. There's also an option if you don't want to modify your path. But it should just take a minute to install that. And once that is installed, you could open up a new terminal. And write fuel up show. Let me see if I can make this a little bit bigger. So fuel up show, and that will show the current toolchain you have installed. So right now I'm using Fork version 0.33.1. So if you're in the future right now and you installed Fuel Up and it's a newer version, make sure to look in the Fuel Up docs and see how to match the version that I have here so you can follow along. Awesome. So the other thing you need to install is the Sway extension for VS Code. So that's just an extension called Sway. You can find it in the extensions marketplace, and it will help highlight some text for you. So now that we have all that installed, we are going to create a new project using the fork command. So that looks like this: fork, F-O-R-C, new, and then the name of our contract. I'm going to call it Marketplace. And that will create a new project for us. And I can open that up in VS Code here. Awesome. Okay, actually, let me go into this Marketplace folder. Okay. So here is the basic project template. There are 3 files in here. You have your gitignore file, fork.toml file, which is the project manifest. So it just has author name. Hopefully this is big enough. So you have the author name, the entry file name, license, and name of the contract and project. And then here's our main contract file. It's called main.sw or main.sway. And there's a sample contract in here, but we could actually just delete this whole thing and start from scratch. So yeah, okay, let's get started with our marketplace contract. So the first thing in any Sway file is on the first line, you have to specify the program type. So if you're coming from Solidity, like the only kind of Solidity file you can really write is a contract. But with Sway, you can write contracts, you can write libraries, and you can write scripts and predicates, which I won't go into today. But the first line is always used to specify what program type. So we're going to write contract. So we just use this contract keyword and then a semicolon. Super simple. All right. So next step is we're going to write our ABI. So ABI is a special keyword in Sway, and it stands for Application Binary Interface. And it's essentially an outline of all the functions in our contract. So we can call this Marketplace Contract. And the API uses these curly brackets here, and essentially we just define each function here, and we'll get to that in a second. The next step is to actually implement the API as a contract. So what that looks like is use the IMPL keyword, which stands for implement, and we use the same name as the API here. So marketplace contract, and then write for contract, and then use these curly brackets here. And then this is everything in here is going to be where we implement the logic for the functions in our contract. Okay, so before we write any functions, we're going to create an item struct. So our program is all based around buying and selling items, right? So we want to define what an item looks like, and we can use a struct to do that. So use a struct keyword, call this item, And a struct is a lot like an object if you're coming from JavaScript. It's essentially, it has a bunch of fields with different types. This would sort of look like an interface in TypeScript. So I'm just going to copy and paste what this item looks like. Okay. So the first field of this item is going to be an ID. And this U64 is a number type, and it's the standard number type used in Sway. And if you're coming from Solidity, you'll know that the standard number type is U256 or unsigned integer 256 with 256 bits. The standard for in Sway is 64. There are special libraries you can use if you need numbers bigger than that, but we shouldn't need that here. So our ID is going to be a number. Our price is going to be a number. We want to be able to track the owners of the items so we know who to send the money to when someone buys it. And if you're coming from Solidity, you'd usually use an address type here. And address actually is a type in Sway. We could use address here. But identity is actually an enum. And what that means is essentially it can be one of several options. And there are only two options for this enum. And that's an address or a contract ID. And that's a huge difference between Sway and Solidity, is that contract IDs and addresses are completely different things. So addresses are only used for wallets. They're also called externally owned accounts or EOAs. And then contract IDs are only used for contracts. So when we use this identity type here, we're basically saying we don't care if a contract or a user wallet wants to buy or sell items. It's not important to us. But theoretically, if that was important to you, you could specify, okay, only a wallet address can be the owner or seller of an item. All right, so the next field we have is metadata. And this is a string with 20 characters. So all strings in Sway have to have a fixed length. And if you imagine, like on Amazon, if you're looking at a product, there's a bunch of images associated with it. There's a description, there's a name. There's all this data that we either can't or don't want to host in our contract. So this field is essentially saying, all right, let's just have an outside off-chain piece of data that has a 20-character reference ID that we can point to in our app to get all of the other associated information about the item that we don't necessarily need in the contract. And the last field we have is total bought. And that's also going to be a number, and it's really just going to be a counter of every time someone buys an item, we can increment this number by 1. Okay, so now that we have our item, we can actually write some of the functions. So the first function is going to be to list an item. So that looks like this in our ABI. And you'll notice right away that VS Code's mad at me because this functions in the ABI, but it is not in the contract, and those two must match. So I'm going to paste the exact same thing in here and just add curly brackets. So what this function does, first, you'll notice there's this special annotation here, hashtag, like brackets, storage, read, write. These are special storage permissions that we'll get into in a sec when we add our storage block. But essentially what we're saying is we're going to read from the state in our contract and then permanently update it. And so without this, our function wouldn't be able to make any persistent changes. So the next thing we're going to add, actually before we add any logic in here, is add our storage block. So A storage block looks a lot like a struct, actually. Use the storage keyword, and there's no name for it, but use curly brackets. And the fields are essentially the different variable names that you're going to want to use for any persistent variables you have. So we're going to have two variables here. The first one is just going to be a counter that we can use. So every time someone lists a new item, we can count, one new item was listed. So we're going to use item count. And if you'll notice also, then all of these variable names here use snake case, which is standard for Sway. So we're going to define the type here. Again, almost looks just like the struct, but the only difference is we're going to define or initialize this variable with a value. So it's going to start at 0. And then we're going to add one more thing here, which is a mapping, which is where we're going to store all of these item instances. So we're going to call that item map, and it's going to be of type storage map, which is a special type built into Sway. And that looks like this, where the type uses a generic. So in here, you'll pass in the key and value types. So we have a number for the ID here for the item. So we want to be able to look up an item by its ID. So we can use U64 as the key and then the item struct type as the value here. And we can initialize this to an empty storage map with these curly brackets. Okay. So now we can actually list the item and then make these read and write storage changes. So the first thing we want to do is listing an item is think about how we're initializing a new item struct, and that looks like this. So the ID we're going to get from this item count here, the price is going to be passed in as a parameter, and so is the metadata. Total bought is going to be initialized to 0, and so that only leaves this identity for the owner here. So that's really the missing piece we need to create a new item struct. So if you're coming from Solidity, you'll know that this is called the message sender. If you want to get the person who sent the transaction, who called this list item function, we can get the message sender, and that comes from the Sway standard library. So it's not immediately available yet. So we have to import it. And to import something in Sway, we use this format here. We use the use keyword, and then we're importing it from the standard library. So we use std and then these double colons, which goes into like the sub libraries in here. And to get the message sender, we're going to be getting it from the auth library. And that just looks like this. So message sender, put a semicolon at the end of this whole import statement. And then we have this message sender function available to us. So now in our list function, list item function, we can say, here is our message sender. So let sender equals message underscore sender, and call that function. And this function returns a result type, which is a special type. It can seem a little confusing at first, but it's actually really simple. Essentially, it just means that this function could potentially return an error, and it will probably return an identity, but there are a few edge cases where it might not. So we're going to assume that, we don't really want to deal with those edge cases here, and just to get the actual result by using this unwrap method. And so essentially it seems a little confusing, but you don't really need to worry about this too much. this will return the identity of the sender of the function. So that can be either an address or a contract ID again. Something else we want to do is increment this item count, right? So to do that, we can access storage with the storage keyword and then use a dot and then the name of the variable. So storage dot item underscore count, and then we can just say plus equals 1. And so it looks like a lot of other programming languages, we could also use storage.item count equals storage.item count plus 1. And so now we just know when we get this item count, one item has been listed. And all right, so the next thing we need to do is create a new instance of an item. So that's going to look like this. Let new underscore item equals, and then we use the name of the struct and these curly brackets, and then just define it how, like, if you're familiar with JavaScript, how you define an object where we have the key and the value. So the ID, we're going to use the item count here. The price and the metadata is passed in. The sender we defined earlier, and total bought is 0. And then finally, we're going to add this new item we created into this item maps in our storage. So what that looks like is, again, we'll use the storage keyword to access the variable. And this is actually really helpful because it prevents naming conflicts. So I don't have to worry if anything, if I want to name something else item map in my function here, then that doesn't conflict with this item map in storage. So to add something to this item map, we can use the insert method, and we just insert the key and the value. So the key in this instance is going to be this item count, which we're using for the ID. And then the value is going to be new underscore item, and that with a semicolon, or semicolon. And there we have our list item function. Awesome. All right, next function, we're going to be able to buy an item. So this function looks really similar, but it has this annotation right here, but it also has this payable keyword. And remember, whenever you add something to the API, it has to be in the contract, and your editor will get mad at you right away if you don't have it. So I'm going to add it down here, and I'll go back up to the API. So this function is also going to be reading and writing from storage. We also have this payable keyword right here, and that just means that we expect the caller of the function to also send funds with it. So if you're coming from Solidity, again, you'll probably find that familiar. All right, so again, we have the exact same function down here. Everything has to match. And we're getting the item ID as a parameter. So we're gonna first look up this item in our item map using this ID. So that looks like this, with item equals storage.itemmap.getID. And we'll need that in a little bit. But we're also going to need to get the message sender. Or actually, maybe we don't need that yet. All right, so the next thing we're going to do is actually check the amount and assets that are sent in the function, right? So someone's going to buy an item. We want to make sure that they're paying the correct price for it. So the way we can do that is first, we're going to check the asset ID sent. So coming from Solidity, this is probably new to you. In Solidity, you can only send the base asset. So for Ethereum, you can only send ETH. Polygon, you can only send Matic. But with Fuel, each contract can create its own native token that can be sent with a contract call natively. So first, we want to check what asset is being sent, because it could be anything. And the standard library has a built-in method for this. So what that looks like is we'll go all the way up to our imports and add this call frames. And then the method is called message asset ID. And we can go back down to this by item function and then get the ID by calling that method. So let asset ID equals message asset ID, and you'll see that it returns this contract ID type. And the next step is we want to make sure that it's the correct asset. So we could set this to any asset we wanted, actually. We could make sure that people can only buy items from a certain contract address, or using a certain type of asset. That could be whatever, but just to keep it simple here, we're going to make that the base asset ID. So that's also a built-in method in the standard library. And so just like I said, the base asset for Ethereum is ETH, for Polygon it's Matic. So this would just get whatever base asset of the blockchain that this contract is deployed for. So we're going to be checking that the asset ID is equal to this base asset. And the way we can do this check is using this require macro or method. So that will look like this: require asset ID to equal the base asset ID that we imported from the standard library. And if it's not, then this whole function will revert, and here's our error message. It was the wrong asset. All right, so the next thing we want to check is that we know we're sending the right type of asset, but we want to make sure they're sending the right amount. So again, we can import one more thing here, which is the message amount function from the context library. So back down here, the amount is going to be equal to just calling this message amount function. And then we're going to want to make sure that that amount is at least equal to the price. So we can say require amount is greater than or equal to item.price, or it's the wrong amount. Awesome. All right, so there's two more things we need to do. So first, we need to update the total bought field for this item. So the way we do that, just to remind you again, that's this field right here, which is initialized to 0, and it's stored in this item map. So in order to make this update right here, you can say item.totalBought plus equals 1. But you'll notice here that it's upset at me. And the reason is because I'm not using this mute keyword here, which makes this variable immutable. So all variables are by default immutable, except for storage variables in Sway. So because I'm defining it here locally, I'm making a copy of it. Essentially, we're going to say this is mutable. I'm updating that field right here, and then I'm going to overwrite the previous value by just using this insert method again. So insert the ID is the key, and then this item that we just updated will replace the old item that just had total bought as 0. Awesome. Okay, and then there's one more thing we need to do here, which is this customer sent money. It's supposed to go to the owner. So the way we can do that is there is another method from the standard library. You might guess the standard library is like a huge part of Sway. There's all these really helpful methods that instead of just being built in globally, you can choose when you want to import them, so you don't have a ton of bloat. So we have this transfer method at the end here. We can call it, and all we have to do is pass in the amount, asset ID we're sending, and then who we're sending it to. So we're going to send it to the owner, and this transfer function accepts an ID for the to address. So yeah, that's our whole by item function. Okay, and there's two more functions we want to do. We have almost everything done, right? People can list items, we can buy items, but if we're thinking about, let's say we want to build a front-end application and we want to be able to list all of the items for sale. We can add a couple functions that will allow us to do that. The first one is this get count, which is just really simple getter function. We're just going to give it read access to storage, and it's just going to return this item count here from storage. So it's returning a U64, which is the same type. We have this count here. Just copy that, and at the end of the contract here, we can paste and then replace semicolon with curly brackets. And then it's still mad at me because I'm not reading from storage yet. So we're going to do that right now. Okay. So again, we're going to use the storage keyword and to just access the item count. And then in Sway, and actually in Rust too, if you have the semicolon, then nothing will get returned. But if you omit a semicolon for the last line of a function, then it will return this value. So this is essentially getting this item count, and then because there's no semicolon here, we're returning the value here. And then the last function we need is a function to get the details for a particular item. So we know how many items there are. We want to be able to loop through that count and get the details for each one. And then in our front end, we have that metadata string, and we can get all the other information that we would need. So again, we're just going to be reading from storage. This item's get item function is going to take an ID, and we're going to return a type of item. And put that in our contract here, and then really similar to above, we're just use the storage keyword, and then we're going to get this from the item map, and we're going to use the .get method and pass in the ID here, and then omit the semicolon at the end of this line, and this will return the item that is returned from the get method. So that is our whole contract. Once you have built a contract or written one, you can build it with fork by using command fork build. And it should just tell you that everything is okay. So if there's anything wrong with your contract, if you omit a semicolon here or something, and then build, maybe that didn't work, but if, we have, let's say we have this omitted and we build, it will tell you that there is an error here and it won't let you build the contract. So if you're always unsure whether it's working or not, use fork build and the compiler will tell you everything that's wrong. So we're not going to go through how to make a front end, but I have a small demo front end. And this is sort of what they would look like. So I'm not using any database to store any actual product information here. you can imagine this is sort of just an ID to some database, or it could possibly be like an IPFS CID. I think that would have to be 59 characters. But you could store everything on IPFS and then just make a call to get that data, like all the images and stuff. And yeah, we're essentially just using these 4 functions. We're getting the count, so that there are 3 items listed. We're looping through them all, getting each item information. We have the item ID, so we can pass that into a by item function. And then separately, there's a form to list an item. And yeah, that's our marketplace contract. I don't know, anyone has any questions?
I guess I have a question for you, Sarah. This is coming from Billy, and I'll just share it right here. But he was asking in regards to the standard library for the tokens. Is it similar to OpenZeppelin for ERC20, 721, etc.?
That's a really good point. So in a lot of ways, it is similar, but they're not quite standards. They're more like tools. And the cool thing about, I guess one similarity is like, OpenZeppelin contracts, they're written in Solidity, they're Solidity contracts. And the Sway standard library is written in Sway. And they're really just helper functions in Sway to help you out. And you can contribute to that if you want to and, update it. So there isn't an equivalent for ERC20 or these types of tokens yet. For tokens in particular, for ERC20, there is a whole separate native token that you can mint, and there are standard library functions to mint the native token. So it doesn't work exactly the same, but yes, it's sort of, there are helper functions to mint tokens, definitely.
Okay, awesome. And then another question that was asked repeatedly, but just is the code going to be available on GitHub so that they can get started as well?
Great question. I don't know how I can share a link.
I'll be able to send it over.
Okay. So essentially, yes, this is on my GitHub. It's just at my username is Sarah Schwartz and /sway-marketplace/simple. See if I can post it in our private chat, and then maybe you can share it.
I just got it. Okay, we've got another question, which is asking, what is the roadmap to become a Fuel dev?
That's a good question. Okay, so I would say this is probably step 1 is to learn Sway and build a contract. And then the next thing you could do is write some tests in Rust. So we have a Rust SDK, and we also have a TypeScript SDK. And those are the main ways you can interact with the contract that's on Fuel. And you can run it locally. You could also deploy it to the testnet. And so, yeah, I would say write some tests in Rust. If you're not familiar with Rust, try to learn some basics of Rust. I promise it's not as scary as it seems. And especially in the context of writing tests for Sway, like you don't need to know all of Rust, right? Rust can do a lot of things. And to write tests for your contract, you don't need to know everything. And I promise it's not as hard as it seems. And then if you want to get really advanced, you could also, we have a GraphQL API that just returns information directly to our node. or from our node, and you can like sort of build some block explorer type thing with that. We also have an indexer service, which is kind of like the graph, if you heard of that, where you can build your own indexer for a contract. So yeah, there's a lot of different things you could do with that, and you can pretty much find all these links. Our website is fuel.network, and under this developers tab, there's a ton of links. There's also, if you go to the main Fuel book, which is if you hit read the docs, under this for developers section, there's all these links. And yeah, I would say this is a really good roadmap for learning all about Fuel.
Okay, awesome. Another question that was asked by Protocol Whisperer is, can we deploy the code to the Fuel testnet?
Yes, you totally can. I don't know if I'm going to go through that whole process right now, but it's really quick. And if you go to our developer quick start, which is in our Fuel book, like if you hit this read the docs button, it'll open this up, and then developer quick start will walk you through. It walks you through building a basic counter project, but it also will do all the setup for Fork Wallet, which is like a wallet CLI, which you'll need to set up to deploy a contract. And what deploying looks like is, it's really simple. It's just this one command here, fork deploy, and then the node URL, and set gas price to 1. And then there's a little bit back and forth. It will ask you for like what wallet you're going to use, and that's what that looks like is this fork wallet. It's a tool that comes with Fuel Up, so you don't need to install anything else if you already have Fuel Up, but you'll have to do a little bit of set up an account and password and all of that. But yeah, you can find the instructions for deploying on this developer quick start page.
Okay, awesome. And then just to clarify, does the Fuel Up provide all the functionalities to kind of get started right away, or do you prefer, or would you recommend us to get started with the developer quick start?
Yeah, so the developer quick start will also have you install Fuel Up. So Fuel Up is really just the like tool manager. It just sort of manages the installation and updating of versions for the fork tool. Yeah, so it will, if I do that Fuel Up show again, it will install fork, fuel core, and fuel indexer. Yeah, does that answer your question?
Yeah, no, absolutely.
Okay.
Sounds good. Are there any last minute questions? Feel free to ask in the chat. But yeah, Sarah, thank you so much. Boom. Thank you so much for the workshop today. I was trying to do it simultaneously. I still have to actually kind of go through it myself to make sure that it's running properly. And I didn't take advantage of understanding it versus just like getting it done. So I have to really kind of dive in there.
Sure.
But definitely super excited to start building with Fuel. And thank you so much.
Yeah, thank you. It was really great being here.
Okay, awesome. And for anyone else that has any questions, feel free to hit up Sarah on Twitter. But until next time, take care, guys.
Bye.